Yeah, good evening once again, children.
Good evening, ma'am.
So this is the fourth chapter in NCRT Maths textbook, quadratic equations. So we know that ax squared plus bx plus c is a standard form of a quadratic polynomial in one variable x. For example, 4x squared minus 5x plus 6. So this is an example of a quadratic polynomial in one variable x. So here the value of a is 4, the value of b is minus 5, and the value of c is 6. Ax squared plus bx plus c is the standard form of a quadratic polynomial in one variable x. When this polynomial is equated to 0, this is the standard form of a quadratic equation in one variable x. So this is the standard form. This is the standard form of a quadratic polynomial in one variable x. When you equate this to 0, this is the standard form of a quadratic equation in one variable x. So here a, b, and c are real numbers. A, b, and c are real numbers. But the most important condition is that the coefficient of x squared, which is a, should not be 0. A should not be 0. A should not be 0. So ax squared plus bx plus c is equal to 0 is the standard form of a quadratic equation in one variable x, where a, b, and c are real numbers and the coefficient of x squared, which is a, should not be 0. Because if it is 0, then it will not be quadratic. Because if it is 0 x squared plus 4x plus 5, then 0 x squared is 0. There's nothing there. So 4x plus 5 is linear. It's not quadratic. Now 5x squared. This one is a 5x squared is equal to 0. This is a quadratic equation in one variable x. This one is a quadratic equation in one variable x. It's quadratic because the power of x is 2. The power of x is 2. So 5x squared is equal to 0 is a quadratic equation in one variable x. 5x squared minus 5 is equal to 0 is also a quadratic equation. Okay, say minus 8 is equal to 0. 5x squared minus 8 is equal to 0 is a quadratic equation in one variable x. 5x squared plus 7x is equal to 0. 5x squared or anything like say minus root 3x squared plus 7x is equal to 0. Okay, minus root 3x squared plus 7x is equal to 0 is a quadratic, is an example of a quadratic equation in one variable x. Because in all the examples, we have the highest power of x is 2, variable x power 2. So since the highest power of x is 2, the equation is a quadratic equation. So here also, power of x 2, highest power of x is 2, highest power of x is 2, which makes the equation quadratic. Just a minute, children. So children, root 7 x squared is equal to 0 is a quadratic equation in one variable x. minus 3 by 5 y square is equal to 0 is a quadratic equation in one variable y. Minus z square plus root 7z is equal to 0. Minus z square plus root 7z is equal to 0 is a quadratic equation in one variable z. Because the power of z is 2, the power of y is 2, the power of x is 2. So it's not that all the three members must be present. If all the three members are there, we call it a pure quadratic equation. A pure quadratic equation. A pure quadratic equation. It's one in which you have all the three terms. That is the ax square term, the bx, and the c term. So like if you have minus root 3x square minus 5 by 7 x plus root 2 is equal to 0. Minus root 3x square minus 5 by 7 x plus root 2 is equal to 0. This is an example of a quadratic equation, a pure quadratic equation, because you have all the three terms, the x square term, the x term, and the constant. But it's not necessary that a quadratic equation must have all these three terms. It must have the x square term, that's all. The others are optional. It may or may not have the other terms. The x square term is compulsory. For an equation to be quadratic, for an equation to be called quadratic, the x square term is compulsory. The x and the constant, the x term and the constant term, they're optional. The x square term can come with the x term, or the x square term can come with the constant term, or all the three terms can be there, but the x square term must be there to make it quadratic. Yeah, take a screenshot of this slide, children. So you can just take up this alone. Please give the name of the chapter quadratic equations and write on only till here. If you want to write the whole thing, you can take a screenshot and write it later. Please give the name of the chapter quadratic equations and write down only till here. If you're interested in reading the rest of it, take a screenshot, leave some space, and you can write it later. Done writing, children?
Yes, ma'am.
Yeah. Yeah. Is this one quadratic, children? Is this one quadratic?
No, ma'am. No, ma'am.
Yeah. Sashank, right?
Yes,
Yes. Yeah. Others, please share your thoughts.
ma'am. No, ma'am.
Okay. Yes, all of you. Madhumita and Sashank have answered. What about the others?
No, ma'am. It's not a quadratic equation.
No, ma'am.
Ritika, you were not there in the last class.
Which last meeting, ma'am?
Yeah, circles yesterday.
Yes,
Yesterday
ma'am.
after.
Last yesterday I was not there.
Yeah, and you don't request for the recording also. How do you manage?
Ma'am, I asked notes from Raghavi, ma'am. I want to write. If I have doubts, I'll check with the recordings.
Where will you find the recording?
No, ma'am, I asked notes like whatever they wrote in the class.
Okay.
So I'll check with that. I'll refer with that. If I have doubts, I'll refer the recording. I'll ask you, ma'am.
How can you understand? Have you learned this chapter in school, circles?
No, ma'am. I could understand something. Like if I didn't go through it all of that. So if I have
But
doubts, I'll ask you for
what
the
notes did
recording.
you write? You have already written the notes, is it?
No, ma'am. I asked for her. I didn't write that. I didn't refer that.
Okay, what did she give you? You asked Raghavi, and what did she give you? She gave you
Ma'am.
the notes, is it?
Yes, ma'am.
But we didn't write anything at all.
Okay, no, ma'am. She didn't give. I asked her. She told she'll be helping me.
No, this is, I don't think, I don't know if it's okay for you, but for me, it's not a responsible way of handling, a session which you have missed. You should
Okay,
have
ma'am.
got in touch with me and requested for the recording. If you
Sorry,
can
ma'am.
refer
I'll
the
see the
notes,
recording.
if you can refer the notes and understand, then why class? Then you can always refer to the notes, no?
Sorry, ma'am. I'll see the recordings.
Oh, anybody see? This applies to everyone. You miss a session, you have to get in touch with me and request me for the recording. Simply writing the notes, how will you understand? And circles, since the time we started circles, I've only been lecturing in the sessions. You don't have notes with you. I'm going to upload it in the library and then let you know. And you're going to write it from there later. Students, if you miss a session, see, every session is being recorded so that I can provide you with a recording in case students miss a session. Make use of that. Please reach out to me, text me, and request me for the recording. I'll share it with you. Yes, children, coming back to our question 9. So it is not a quadratic equation, one variable x, right? All of you agree with that?
Yes,
Because the
ma'am.
power of x is not 2, correct? Okay. Anyone disagrees? Nobody. Okay, very good. Yes, children, please expand. What is a plus b the whole cube? What is a plus b the whole cube? A
A
cube
cube plus B cube.
plus b cube plus 3ab into a plus b, right?
A plus B.
Very good, very good. So this will be, how do you expand this one? It will be a cubed, x cubed plus 2 cubed plus 3ab, 3 into x into 2 into a plus b, x plus 2 is equal to x cubed minus 8. So x cubed plus 8 plus 6x into x plus 2 is equal to x cubed minus 8. X cubed on either side gets cancelled. So 8 plus, when you multiply, 6x squared, again multiply, plus 12x is equal to minus 8. So 6x squared.
It's x cube plus 8 now, ma'am, on this side.
Okay, is it plus 8?
How's it mine? Oh, okay.
Okay, so 6x squared plus 12x plus 8 is equal to 0. So 6x squared plus 12x plus 16 is equal to 0. When you divide this by your 2 throughout, you get 3x squared plus 6x plus 8 is equal to 0. Now tell me, is this quadratic or not?
It's quadratic, ma'am.
Yes,
It is
ma'am.
quadratic. It is quadratic. So the lesson we learn from this is that we should not judge, like you should not judge a book by its cover. In the same way, you should not judge if an equation is quadratic or not just by the face of the equation. Looking at the equation, looking at the powers 3, we should not conclude that the equation is quadratic or not quadratic. We need to simplify. We need to simplify and then look at the last step and then conclude and then decide. So we have to expand x plus 2 the whole cube using the identity a plus b the whole cube. On the right hand side, there's nothing to simplify. Don't think it is in form a cube minus b cube. So you should write it as a minus b a square. No, you're not factorizing. Expand, that's all. X cube minus 8 is already like expanded. You should not factorize it. You don't have to treat it in the form, treat it as a cubed minus b cubed and write it as a minus b. Sorry, you don't have to treat it as a cube minus b cube and write it as a minus b, a squared plus ab plus b squared. Don't factorize, expand. Only expand. Understand, all of you? So if some of us did not understand, we'll just do it again. A plus b the whole cubed is a cubed plus b cubed plus 3 into a into b, 3 into a into b into a plus b. This is how we expand a plus b the whole cube is equal to the RHS as it is. Now this is x cubed plus 8 plus 3 into 2, 6x is equal to x cubed minus 8. X cubed on either side gets cancelled. Now don't add 8 and 6. It's not 8 plus 6. 6x has to be multiplied with x plus 2. So this 8 as it is plus 6x squared plus 12x is equal to minus 8. Or you can bring minus 8 to the left hand side. Plus 8 is equal to 0. So 6x squared plus 12x plus 16 is equal to 0. So 3x squared dividing by 2 throughout, 3x squared plus 6x plus 8 is equal to 0, which is a pure quadratic equation. So like this, children, look at the heading. Which of the following are quadratic equations in X? So we have to work. We'll have to work and then conclude. Just by looking at it, you cannot decide if it is quadratic or not. All right.
Yes, ma'am.
Yeah. So these are the different methods of solving a quadratic equation. Factorization method, completing the square and quadratic formula. Completing the square was removed from the syllabus last year. So I think the same thing continues now. I'll get started with this. We'll do this and this, and then I'll just check with you if any of you learn this chapter at school. I can just check with you if you've learned this one. Last year this was deleted. Okay, so these are the different methods of so.
It's deleted, ma'am.
Sorry.
This year also it is deleted.
Oh, thanks, Arjun. Yeah, okay. So completing the square we will not learn. So we learn how to solve a quadratic equation using factorization method and by using the quadratic formula. Okay. So the quadratic formula. So factorization method we have seen by splitting the middle term. You know how to factorize, you know how to find the values of x or the roots of a quadratic equation by factorizing, splitting the middle term, finding the sum, product, and the two numbers that satisfy the sum and the product. Factorization method you're familiar with. So we'll see the quadratic formula. The quadratic formula goes like this. If the quadratic equation is of the form ax squared plus bx plus c is equal to 0, then the roots of this equation are x is equal to, that is, you'll have to find the two values of x, right? We know that a quadratic equation has at most two roots. A quadratic equation has at most two roots. There will be maximum two values of x that can satisfy the equation. There can be a maximum of two values of x that can satisfy the equation. Okay, so before we see that, now for example, x squared minus 5x plus 6. Okay, x squared minus 5x plus 6. Now let's check when x is equal to 2 and x is equal to 3. All right, when x is equal to 2, when x is equal to 2, what do you get? LHS is equal to 2 square minus 5 into 2 plus 6, 4 minus 10 plus 6. So this is 0. RHS is also 0. So x is equal to 2. When x is 2, the equation is satisfied. When x is 3, when x is equal to 3, LHS will be 3 squared minus 5 into 3 plus 6. So 9 minus 15 plus 6, 0. RHS is also 0. So these values 2 and 3 satisfy the quadratic equation x squared minus 5x plus 6 is equal to 0. Now, there are so many real numbers. The collection of real numbers is infinite. Of those infinitely many real numbers, only these two numbers, 2 and 3, can satisfy the quadratic equation x squared minus 5x plus 6 is equal to 0. There is no other value of x that can satisfy this quadratic equation. Minus 2, minus 3, whatever, you try whatever you want. Only these two values. Imagine there are infinitely many real numbers. There are infinitely many real numbers. Of those infinitely many real numbers, only these two numbers, 2 and 3, can satisfy this quadratic equation x squared minus 5x plus 6 is equal to 0. How do we believe that? So use x is equal to 2 in the LHS, and you see the value of the LHS is 0. RHS is also 0. So that means x is equal to 2 satisfies the quadratic equation. X is equal to 2 satisfies the quadratic equation. Similarly, 3 also satisfies the quadratic equation. The value 3 also satisfies the quadratic equation. So 2 and 3 are the two zeros of the quadratic equation. Now consider this one. Okay. So here, when x is 2, let's try when x is 2. When x is equal to 2, the LHS will be 2 square minus 4 into 2 plus 4. So 2 square is 4 minus 8 plus 4, which is 0. Now for this quadratic equation, only 2 is the only value that can satisfy this quadratic equation. There is no other value of x that can satisfy this quadratic equation. 2 is the only. So again, of so many numbers, there are so many real numbers. Of those numbers, only this number 2 can satisfy the quadratic equation x squared minus 4x plus 4 is equal to 0. So in the left-hand side, in place of x, when you use 2, the equation is satisfied. LHS is 0, RHS is also 0. There is no other value of x that can satisfy this quadratic equation. If you consider this one, if you consider this quadratic equation, okay, x squared plus 10 is equal to 0. Now, there is no value for x. For this, there are many examples. These are not, so I'm just giving you an example. There are many such equations. So there is no value. Now, if you consider this quadratic equation, x squared plus 10 is equal to 0, there is no value of x that can satisfy this quadratic equation. There is no value. There are so many real numbers. Not one real number can satisfy this quadratic equation. That's because whatever be the value of x, whether positive or negative, when you square it, it's going to become positive. Whether x is positive or negative, when you square it, it will become positive. So this positive value of x squared plus 10 will be another positive value. It cannot be 0. X squared will always be positive, or x squared can be 0. If you take x as 0 itself, if you take x as 0, 0 squared is 0. Anyways, it's 10. So plus 10 is 10. So x squared is always positive, or it can be 0. Because whether the value of x is negative or positive, when you square it, it will become positive. Or when x is 0, 0 square is 0. So 0 plus 10, 10. Or that positive value plus 10 will be a greater positive value. You will never get 0. So this is an example of a quadratic equation where there is no value for x that can satisfy it. So in this case, there is no value for x that can satisfy the quadratic equation. So that means the quadratic equation has no roots. The quadratic equation has no roots. No roots. In this case, there is only one value of x that satisfies the quadratic equation. So here, the quadratic equation has only one root. Or we say two equal roots. Two equal roots. I'll tell you why two equal roots later. Because when you work this, when you work this, you'll get x minus 2 into x minus 2 is equal to 0. So x is equal to 2 in both the cases. X is equal to 2, x is equal to 2. So two equal roots you'll get. When you factorize, you'll get x is equal to 2 in both the cases. So two equal roots or one root. One root, which means two equal roots. And here, and here, two distinct roots, two different roots, two distinct roots. So these are the three cases. The quadratic polynomial, the quadratic equation may not have any root. The quadratic equation may not have any root. That is, there is no value for x that can satisfy the quadratic equation. So the quadratic equation has no roots. Or the quadratic equation can have only one root or two equal roots. One root or two equal roots. That is, there's only one value of x. Whatever variable, x, y, z, whatever is the variable. So there's only one value of the variable, one value of x that can satisfy the quadratic equation. So we say one root or two equal roots. And then there can be two values, two different values, not two equal values, two different values like 2 and 3 that can satisfy the quadratic equation. Not more than this. No quadratic equation can have more than two zeros or more than two roots. No quadratic equation can have more than two roots. Maximum number of roots a quadratic equation can have is 2. It may not have any root at all, or it may have one root, that is 2 equal roots, or 2 roots, 2 different roots, 2 distinct roots. Don't write, children. No roots, one root, 2 roots. One root means 2 equal roots. Equal roots are also called coincident roots. Coincident roots. Two roots or 2 distinct roots. 1 second, I'll just have some water and come back. Yes, children. So you need to remember these terms. Equal, unequal. Equal also means coincident. Unequal also means distinct. No roots at all. No roots at all is just have it on one side. Equal roots, unequal roots. Equal roots are also called coincident roots. Unequal roots also called distinct roots. So that's why we say a quadratic equation can have at most two roots. At most two roots means no roots, zero roots, one root, two roots. At most two roots. A quadratic equation can have at most two roots. That means no roots, one root, or maximum two roots. So now ax squared plus bx plus c is equal to 0 is a standard form, and x is equal to, this is the quadratic formula, x is equal to minus b plus or minus root b square minus 4ac divided by 2a. So you know ABC. A is the coefficient of x squared, b is the coefficient of x, c is the constant. So minus b plus or minus root of b square minus 4ac by 2a is the quadratic formula. Now this expression b square minus 4ac is called the discriminant. Discriminant. Okay. The expression b square minus 4ac is called the discriminant because this expression determines the nature of the roots of the equation. This expression determines the nature of the roots of the equation. Okay, so how does it decide the nature of the roots? Now, if b square minus 4ac, the value of this expression is negative. Supposing the value of this expression is negative, so it'll be like, say, like root of minus 10. So we know that square root of a negative number is imaginary. It's not real, it's imaginary. That means the quadratic equation will have imaginary roots or no real roots. See, when we say no roots, that means no real roots. When we say, see, we are talking only about real. Sorry, children, 1 second. So we are talking only about real roots. Okay. So when we say it has no roots, that means no real roots. So that means the roots are imaginary. No real roots, meaning the roots are imaginary. So if b square minus 4ac, supposing b square minus 4ac is minus 10. So square root of minus 10 is not real. It's imaginary. It's not real. So in that case, the quadratic equation has no real roots, no roots or no real roots. So see, this one only decides. From this you can make out. If you find b, it's enough if you find b square minus 4ac. If this is negative, that means the given quadratic equation has no real roots. So supposing you find b square minus 4ac and it is 0. Supposing it's 0, square root of 0. What is square root of 0? 0. So that means this portion is completely not there. This plus or minus will not be there. So minus b by 2a. X is equal to minus b by 2a. Only one value you're getting. Minus b by 2a, that's all. So when d is equal to 0, the quadratic equation has one root or two equal roots. See, the value of b square minus 4ac, that is the value of the expression under the square root, can be negative, 0 or positive. It can be negative, 0 or positive. If the value of b square minus 4ac is negative, that means the quadratic equation has imaginary roots. If the value of b square minus 4ac is 0, so square root of 0 is 0. So this whole thing is 0. So we are left with only minus b by 2a. And minus b by 2a is only one value. What about the other value of x? No, there is no other value. There's only one value, minus b by 2a. So in this case, when b square minus 4ac is 0, the quadratic equation has equal roots. That is only one root or two equal roots. So if the value of b square minus 4ac is positive, okay, if the value of b square minus 4ac is positive, okay, so positive meaning supposing it is like positive, it can be a perfect square or an imperfect square. When it's positive, it can be a perfect square like 25, or it can be an imperfect square like 30. It can be a perfect square or an imperfect square, whatever it is. So when b square minus 4ac is positive, the quadratic equation will have two roots. Why two roots? Because minus b plus root b square minus 4ac by 2a is one root, and the other root is minus b minus root b square minus 4ac by 2a. That's the other root. One with the plus sign, one with the minus sign. Minus b plus root b square minus 4ac by 2a, and minus b minus square root of b square minus 4ac by 2a. So like that, you have two different roots. So since b square minus 4ac determines the nature of the roots of the equation, b square minus 4ac is called the discriminant in the quadratic formula. It's called the discriminant in the quadratic formula. So ax square plus bx plus c is equal to 0 is a standard form of the quadratic equation in one variable x. So the quadratic formula goes like this: x is equal to minus b plus or minus root of b square minus 4ac divided by 2a. B square minus 4ac is called the discriminant, represented by capital letter D. Discriminant. It's called the discriminant because it determines the nature of the roots. It determines the nature of the roots of the quadratic equation. So how does it decide? Now the square root of b square minus 4ac. Okay, if supposing this is negative, b square minus 4ac is negative. Okay, so negative meaning, so like square root of a negative number like this. This is, so square root of a negative value we know is not defined. There does not exist the square root of a negative number. That means there is no real value. The value is imaginary. So when b square minus 4ac is negative, the quadratic equation has no real roots. It has imaginary roots, no real roots. When b square, so we just take up the three broad cases. When it is negative, 0, positive. When b square minus 4ac is negative, 0, positive. So when b square minus 4ac is 0, so square root of 0 is 0. So that means this one is not there. This is 0, it's gone. So you will have only one value for x, minus b by 2a. So when b square minus 4ac is 0, the quadratic equation will have only one root or two equal roots. When b square minus 4ac is positive, then you will have, when it's positive, then you will get two values. How two values? How two values? Because once it will be with plus and then it will be with minus. So if b square minus 4ac is positive, then the quadratic equation will have two distinct roots. Two different roots it will have. Okay. So you can see here. Let the given quadratic equation be, let the given quadratic equation be ax square plus bx plus c is equal to 0, where a is not equal to 0. Then the discriminant is given by, okay, d is equal to b square minus 4ac. This is the meaning the conclusion. And the roots of the given quadratic equation are alpha is equal to, yeah, you know that alpha and beta are the two roots. We have seen in the chapter polynomials. Alpha is equal to minus b plus root d by 2a and minus b minus root d by 2a. What is d? B square minus 4ac. What is d? B square minus 4ac. So minus b plus root d by 2a minus b minus root d by 2a. So we saw when d is less than 0, when the value of d is negative, roots are imaginary. When d is equal to 0, alpha is minus b by 2a, beta is also minus b by 2a. The roots are coincident. When d is greater than 0, then alpha is minus b plus root d by 2a and beta is minus b minus root d by 2a, where d is b square minus 4ac. Yeah. So this is the summary. Please read. I'll give you 2 minutes time. Got it, children?
Yes, ma'am.
Okay. I think it's time now. We cannot solve, so maybe we'll just do one more of this one. Okay, tell me if this can be quadratic. What do you feel when you look at this? Can this be quadratic?
Yes, ma'am.
Yes, ma'am.
So see here, x plus 2 by x plus x squared. X is the common denominator. You should simplify. I told you, children, you should not, as it is, you should not judge. There is 2x in the denominator. It's not a number. Supposing it was x plus 2 by 5. See, supposing it was x plus 2 by 5 is equal to x squared. Then you can say it is quadratic. You don't have to simplify this because x squared, this is a constant 2 by 5. This is not going to disturb x or x squared. But what we have here is x plus 2 by x is equal to x squared. So let's simplify this. X is the common denominator. So x squared.
Ma'am, it's not a quadratic equation, ma'am.
Yeah, x squared plus 2 is equal to x squared, correct? Common denominator is x. X squared plus 2 is equal to x squared. So when you cross multiply, you get x squared plus 2 is equal to x cubed. So this one is x cubed minus x squared minus 2 is equal to 0. Yes or no, children?
Yes, ma'am.
Yes.
So it's not a quadratic equation. So always please simplify. So when not to simplify, if the denominators are numbers, you don't have to simplify. Like for example, this you don't have to simplify. This one you don't have to simplify. You don't have to take the LCM and all that here. Because the denominator is made up of numbers. 3, 5, that's fine. If see here also the denominator has a number 2, then it's okay. But see, these denominators are dangerous. X squared. You should take up the common denominator, cross multiply, and then decide. All right. So this when we work, we find that it's a cubic equation. It's a cubic equation. It's not quadratic. It's cubic because the highest power of x is 3. Now, when you work this one, see, this one looks like linear, but when you work this, x squared minus 6 is equal to 3. When you cross multiply, x squared minus 6 is equal to 3x. X squared minus 3x minus 6 is equal to 0. This one, which looks like linear, this looks like there is no x squared at all in this. How can it be quadratic? But that is quadratic. This one has x squared in it. So we think it is quadratic, but it's cubic. So like the proverb, do not judge a book by its cover. Do not judge these dangerous equations from the powers. Like the cover here, don't decide from the power like this on the face of it. Okay, there is a 3 here, so it is not quadratic. Here there is no 2. The power, there is no power 2. So it is not quadratic. Just by looking at it, do not decide. Please simplify. And when to simplify? See, such things must be expanded. This one has to be expanded. This one has to be multiplied. You should find the product here. Here also, you must find the products. Open the bracket. Here also, you must expand. Open the bracket. Here also, expand. You need not factorize. Don't factorize. You must expand. Here also, you should open the bracket and expand. Here, LCM. Here also, LCM. Here, LCM. This one is ready. This one, you don't have to do LCM because there are numbers in the denominator. 3 and 5. This you can decide like this itself. Here also, there's a number in the denominator. This is fine. Like this itself, you can decide. This is x squared, x and a constant, x squared, so quadratic. You don't have to worry about this 2 in the denominator. But when there is x or x squared in the denominator, you should simplify by taking the common denominator. Is that fine, children?
Yes, ma'am.
All right. Class use the emoji, raise your hand. Rishmi, Prajit, Madhumita, Danya, Tanishka, Diliban, Sriranjan, Sashank, Florentina, Rakshita, Danya, Ritika, Arjun, again changed. Diliban, Ranjan, Sashank, Florentina, Rakshita, Danya, Ritika, Arjun. All right. I think Raja is missing. Okay. All right, children, was it clear today? How many of you? Yeah, how many of you? Very good. How many of you have learned this chapter in school already?
Me, ma'am.
Sashank, huh?
Yes, ma'am.
Okay. Who else?
It's going on, ma'am.
We are learning.
For whom? Arjun, it's going on, is it?
Yes, ma'am.
Oh, that is, they started in April. They haven't still completed, right?
Yes, ma'am.
Okay.
Same for me, ma'am. They started and they didn't complete it.
Okay, okay. Okay, so Sashank has learned the chapter in full, is it?
Yes, ma'am.
Oh, okay. All right, children. All right, children. So that's it for today's session. Thank you so much. Good night. We'll have a class tomorrow afternoon, 12:15 to whatever time alone. You please check WhatsApp, but we'll have a class tomorrow on circles. All right, children. So that's it for today's session. Thank you. Good night.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, children. Good night.
Thank you, ma'am.
Thank you.